Hello everyone, welcome to the final project of numerical analysis of for 2023. My name is Zecheng, and I'm on behalf of my teammates Raoul and Mark to present this stock prediction project on YouTube. So our motivation is we want to understanding the financial markets, how the stock market movements, trend, and factors, and we also want to apply the numerical methods onto the interpolation and extrapolation. We also want to developing a predictive models that can predict the trend of the stock. We also did data visualization and interpretation to be dedicated to the effective visualization of interpolation of stock data. And then we wanted to optimize the profit. As you can see, the Tesla stock increased 9 times during the last 5 years. That means if you have $100 invested in Tesla in 2018, you will have $900 right now. So to get into the game itself is already beating a lot of people if you just do the long-term hold. And then we got our data from Yahoo Finance. They have a website, and you can grab the data from the historical data part, and you can select all of the options, like date range, right? And you can download a CSV file with a lot of variables, starting price, close price, fixed, adjust, and also trading date, etc. And we only select the date and the close price. Let's talk about our interpolation methods. We split data records into two data subsets. One is trained data, the other is tested data. Let's say there are 365 days in a year, but there is only 250 days as a trading day. Consider the holidays. So we are getting the data from 6 months range, which is about 180 days, but the actual trading data is about 120 days. Then we used 90 days as the trained data and 30 days as the tested data. First, to find the best match function, we use following 3 methods with the 90 days trained data. They are Lagrange, least square approximation linear, and least square approximation by cubic polynomial. And then we compute the expected data from the 90 days. Then we calculate the RMSD between the predicted 30 days data with the test 30 days data to get the RMSD to find the best match function of the prediction model. Therefore, we can determine the best dates to buy and sell stock to reach the maximum profit. To do this, we developed an algorithm, a very classical algorithm called buy and sell stock. It is using 2 pointers, one is on the left, the other is on the right, and each loop you store the maximum price and the lowest price, and then each loop you plus on the left, plus 1 on the left, and minus 1 on the right, until they meet each other in the middle. Then we want to talk about our implementation. We use MATLAB to develop our project. We design our project in object-oriented programming approach. We created a custom class, interpolation methods, where we put every interpolation methods. As you can see, we have a linear function, cubic function, right? And we also produce the slope, and we also put the Gaussian elimination in there. Next, we also create a customer class called analysis, where our stock analysis methods are located. There are several functions like get the data, compute the interpolation functions, find the expected value, use RMSD, and plots, compute the forecast, and other help functions. Here are some other help functions like root mean square deviation and buy and sell max profit. And here is the main file that runs the program, which is very simple, just a couple of lines of code. And here will be our result. As we just mentioned, we did this on Tesla and Apple from May 30th to October 13th this year, as both training data, also the testing data, we try to predict from October 17th to November 27th. Then we will compare the predicted result with the actual result. So this is a Tesla 6 months interpolation. From the left to the right, they are Lagrange, least square linear, least square cubic. As you can see, these three trend line that are in the purple, red, and dark black, they can measure the trend very well. But just from eye, you can see Lagrange has the best. I would say Lagrange for stock market is very accurate. And then we calculate the RMSD based on our prediction. We find out the polynomial has a very big error because it's predicting the stock going very high, and linear relatively is the best. It's better than the cubic. You can see the cubic is predicting the stock going to $450. So what's the best day to buy and sell stock? According to our algorithm, we choosing the linear function, right? And the best day will be from October 16 buying and November 27 selling. So the max profit is $2 something. But the actual best date, based on pure stock price, if you want to look at the lowest price and the highest price, you will see we can reach a max profit of $45. And then here comes Apple. Same thing. We have the interpolation to measure. You can see it's a little bit different from Tesla because Tesla is trending up on the least square linear and least square cubic, but this is trending a bit down. There's also the RMSD for all the functions, and linear function has the smallest RMSD. And based on this, we would predict the best day to buy and sell. It will be the same day because the stock is trending down. Therefore, you shouldn't buy the stock at this moment. But the actual date, you can see is October 26th buying, November 20th selling, and you can have a $24 profit. So based on this, we realize that it is actually very hard to predict when to buy and sell, but if we can predict the trend of the stock, let's say a stock is trending up and the other stock is trending down, we will buy the one that's trending up, right? So that will be a no-brainer choose. But if two stock they are both trending up, we will tend to buy the stock that with the bigger slope. So the conclusion is that our result showing our interpolation methods is good, is permanent. But the trend, I would say the trend for the Tesla is relatively good, and for Apple is good as well. But the prediction for the future is very hard. I remember there's an old saying, or probably a new saying, that when you predict the future has already been changed. So it is very hard to predict a stock because there are so many factors we have to consider. There is another work that we want to do is we want to see what impact the interpolation and the extrapolation. Let's say if a volatility of a stock, or if a stock that's have a very big trading volume, are those things can impact the prediction model, and those are the things that we want to work on. Thanks for watching, and I will see you next time. Thank you.